recording, we're going to be looking at bounds, but in particular solving problems using upper bounds and lower bounds. In higher IGCSE, you will generally find sometimes quite complex problems where you have to solve problems using upper bounds and lower bounds. So let's just have a quick recap on finding upper bounds and lower bounds. It's just something you may be able to do, but let's just have a recap of the different types. So if 780 has been rounded to the nearest 10, what would the upper bound and lower bound be? Half of 10 is 5. Take 5 off 780. 775 is the lower bound. Add 5 on. 785 is the upper bound. 1,350 to the nearest 10. Again, take 5 off of 1,350. Add 5 on to get your upper bound and lower bound. If you want to recap this topic in more depth, there is a recording in the foundation section on this topic. So to the nearest 100, half of 100 is 50. So your upper bound is 2,750. Lower bound, 2,650. Half of 100 is 50. So your lower bound is 16,850. Upper bound, 16,950. To the nearest whole number, to the nearest integer, to the nearest 1. Half of 1 is 0.5, 83.5 lower bound, 84.5 upper bound. Same with the bottom one, half of 1 is 0.5, 168.5 lower bound, 169.5 for the upper bound. Find the upper bounds, upper and lower bounds of the following. So 4.6 rounded to the nearest 1 decimal place. Now, the nearest 1 decimal place, it means 0.1. Half of 0.1 is 0.05. So the upper bound, let me just change the colour here, is 4.65. And lower bound, take 0.05 off 4.6, 4.55. Sometimes I think it helps if you think of it like this. Your 4.6 is 4.60. You can almost see then it's 4.55, 4.65. Next one, 2.82, rounded to nearest 1 decimal place. Upper bound, 28.15. That's your lower bound. And upper bound, 28.25. Okay, next one, so there's 2 decimal places here. So again, this would be to the nearest 0.01, or you can imagine it as 9.570 if that helps. So your lower bound would be 9.565, upper bound 9.575. For D, lower bound 12.965, upper bound 12.975. And this one here, this one confuses people sometimes, but 6.0 is to the nearest 1 decimal place. Upper bound would be 6.05, and your lower bound would be 5.95. Okay, what happens if numbers have been rounded to a significant figure instead? So if this has been rounded to the nearest 1 significant figure, look at the place value of your first significant figure. It's been rounded to the nearest 10. So your lower bound would be 55, upper bound 65. Place value of your first significant figure here, hundreds. So lower bound would be 250, upper bound 350. 9 to one significant figure, nearest whole number, nearest integer, lower bound 8.5, upper bound 9.5. 28 to two significant figures. This is your second significant figure here. So it's the nearest whole number. So your lower bound would be 27.5 and your upper bound would be 28.5. Second significant figure is one decimal place. Your lower bound would be 6.35, upper bound 6.45. Okay, let's have a look at solving problems using upper and lower bounds. This garden area needs to be returfed. The area's rectangular measurements have been rounded to the nearest metre. Even if I ignore the rest of this question, let's just always think, what would the upper bounds and lower bounds be? So 4 metres to the nearest metre. The upper bound would be 4.5, the lower bound would be 3.5. And 5 metres to the nearest metre, lower bound 4.5, upper bound 5.5. Turf is sold by the area needed in metres squared. How much turf should the gardener buy in order to guarantee that he has enough to cover? So he's going to have to find the upper bound, right? He needs the maximum possible to ensure he has enough. So to get the maximum, makes sense, doesn't it? We're going to use an upper bound and an upper bound. Find area we times. So it's going to be 4.5 times 5.5, which is 24.75 metres squared. Next question. Packs of cheese each contain 1.3 kilograms to the nearest 0.1 kilogram. What are the lower bounds and upper bounds for the total weight of 6 packs? As I was saying for the previous question, always get your upper bounds and lower bounds first. So your upper bound would be 1.35 and your lower bound would be 1.25. Now, to get the lower bound for all of the 6 packs of cheese, each packet could be at 1.25. So we just need 6 times 1.25 for the lower bound, 7.5. Now for the upper bound, 6 packs, all at the maximum. Six times 1.35, 8.1. Okay, have a go at these 4 questions. Maybe put me on pause, unpause when you're done. So for this ribbon question, your lower bound is 6.5, upper bound 7.5. Least total length of 10 pieces, 6.5 times 10, which is 65. Greatest would be 7.5 times 10, 75. For question 2, for your barrels, lower bound 25, upper bound 35. Minimum for 4 barrels, 25 times 4, which is 100. And your upper bound, 35 times 4, which is 140. A rectangle has a length 14 centimetres and width 14.5. So your upper bounds and lower bounds are 13.5, 14.5, 4.5, 5.5. Maximum area, 14.5 times 5.5. 79.75. Minimum area, 13.5 times 4.5. 60.75. classes in a primary school are 20 to the nearest 10. So your upper bounds and lower bounds here, 15, 25. There are 7 classes in the primary school. Work out the greatest possible number of students. 7 times 25, 175. So when you add and when you multiply using upper bounds and lower bounds, it's fairly straightforward. When you subtract and divide, you need to be a bit more careful. So Saul weighed 85 kilograms before training, 81 kilograms after, both weights to the nearest kilogram. Find the upper bounds and lower bounds for his weight loss. If this was not an upper bounds and lower bounds question, to get the weight loss, we would just do 85 minus 81, which is 4 kilograms, right? Okay, so it is a subtract question. We need the difference. So let's involve the upper bounds and lower bounds now. 85, upper bound would be 85.5, lower bound would be 84.5. For 81, upper bound would be 81.5, lower bound would be 80.5. Now I'm going to show you this with a bit of a diagram here. Here's 85, here's 81. Here's upper bound, 85.5, lower bound, 84.5. Upper bound, 81.5, lower bound, 80.5. Now, how do we get an upper bound for the weight loss? What is the maximum possible weight loss here? Can you see to get the maximum difference? It's the difference between 85.5 and 80.5, which is not using both of the upper bounds. So to get an upper bound, use the biggest of the biggest, subtract the smallest of the smallest. And to get a lower bound, can you see it would be the smallest difference, which would actually come from here, which would be this one, subtract this one. Okay, maybe have a go at these 3 questions. Put me on pause, unpause when you're done. Okay, so Harry's upper bound and lower bound, 30 seconds to nearest 10 seconds would be 35 seconds, 25 seconds. Peter's rounded to the nearest second, upper bound would be 43.5, lower bound would be 42.5. Minimum difference. So the minimum difference would be the smallest of the, so. For the subtraction, it would be 43 take away 30 if they weren't rounded right. So we need the smallest of this one minus the biggest of this one. So 42.5 minus 35, which should be 7.5. Beaker of water, question 2. A beaker of water weighed 426 to the nearest gram. Upper bound would be 426.5, lower bound would be 425.5. After the water was poured out, the beaker weighed 173 grams to the nearest gram. So your upper bound here would be 173.5, lower bound would be 172.5. We want upper bound and lower bounds for the weight of the water. Okay, so to get the weight of the water, we need to do if we were just going to find the weight of the water from the question without upper bounds and lower bounds, it'd be 426 take away 173, wouldn't it? Seeing as we're using upper bounds and lower bounds, to get the upper bound, so the greatest weight of water, we need this 426 take away the 172.5. which is 254. To get a lower bound, we need the lowest one, the biggest value, minus the highest one, the smallest value. $252. Want my 4 on the end of there for some reason. Okay, question 3. A piece weighing 260 grams to the nearest two significant figures. So upper bound would be 265, lower bound 255. Is cut from a cheese weighing 840 to the nearest two significant figures. So 845, 835. Find the upper bounds and lower bounds for the weight of the cheese. The upper bound would be 845, subtract 255. 590. And the lower bound, 835 minus 265. 570. With division, it's a similar idea. A runner covers 75 metres to the nearest metre. So upper bound is 75.5, lower bound 74.5. To the nearest second, 7.5, 6.5. Find the upper bounds and lower bounds for the runner's average speed. Now, speed is distance over time, so it's a division. Now, when we're doing a division, how are we going to get our maximum possible answer, our upper bound? To get a maximum possible answer, we're going to need the biggest of the biggest divided by the smallest of the smallest. As you can see, the smallest one would fit into the biggest one more times, which is why you get a bigger answer. Like, that's how we get the maximum answer, which is 11.6. And for the lower bound, again, we use our opposites, 74.5 and 7.5, because it's just not going to fit into it as many times, and it's a smaller value. 74.5 divided by 7.5 would give us 9.9. Okay, so we've got a pump delivers 3,260 litres of water in 17 minutes. Find the upper bound and lower bound of the rate in litres per minute at which the pump is working. If this wasn't an upper bound, lower bound question, if we haven't been given the values rounded, it would just be a division. Per minute, how many litres per minute? 3,260 divided by 17. It is upper bound, lower bound. So let's get the upper bounds and lower bounds first. Upper bound is 3,265. Lower bound, 3,255. Upper bound, 17.5. Lower bound, 16.5. Right, now, so to get upper bound, our biggest possible answer, we need the biggest value divided by the smallest. $197, rounded 0.9. And the lower bound we get from doing the smallest of the numerator, divided by the biggest for the denominator. £186. Megan has 2 litres of fruit juice to the nearest litre. She pours the fruit juice into glasses that hold 100 ml to the nearest 10 ml. So 2 litres to the nearest litre, 2.5 upper bound, 1.5 lower bound. 100 ml to the nearest 10 ml, 105 for the upper bound, 95 for lower bound. The lowest number of glasses to be filled, so we want a smallest value, a lower bound. So to get a lower bound, we need the, I've just noticed we have a units of measurement inconsistency here. Right, so what we need to do is convert our something either both into millilitres or both into litres. I'm going to choose to go with millilitres. So we need the smallest for the numerator divided by the biggest for the denominator. 1.5 litres is 1,500 ml. Always check that units are consistent. Now the answer is 14.2. That would be 14 glasses. Okay, with IGCSE Edexcel, I have noticed that a lot of questions you're just given algebra with upper and lower bounds. So just to finish off, let's have a look at these 5 questions. A and B both been rounded to the nearest integer, so we've got 12.5 for the upper bound, 11.5 for the lower bound. And for B, our upper bound is 6.5, lower bound 5.5. Upper bound for 7A. 7A means 7 times A. So the upper bound for 7 times A would just be 7 times 12.5. £87.5. And the lower bound, I'll pop on the other side here, would just be 7 times 11.5. 80.5. A plus B, just need our upper bounds. £24. And lower, oh no. What am I doing here? Need both the upper bounds, 6.5, which will give you 19. And the lower bound, 11.5 for A, and 5.5 for B, 17. Again, for your A times B, to get your upper bound, it's upper bound times the upper bound. £81.25. And your lower bound is your 11.5 times 5.5, multiply both your lower bounds together. 63.25. Okay, let me choose a different colour for 5, 4 and 5. So to get the upper bound for A minus B, just be careful here, right? So the upper bound, don't forget with the subtraction, is the biggest minus the smallest. 7. And the lower bound, smallest minus the biggest. 5. And then for our division again, the upper bound, biggest divided by smallest. 2.3 rounded to 1 dp. And the lower bound, smallest, divided by the biggest. .8 rounded.